Thanks very much for the opportunity to be here with you tonight. My name is Mark, and I'm from a Bay Area company in California called Datastrato. Datastrato provides an open source Apache catalog called Apache Gravitino, which is partly an Iceberg REST catalog and partly a catalog for other purposes. Now, we've heard a lot about Iceberg catalogs tonight, and I want to tell you about some of their technical features, which we'll get to in a minute. But one of the things that's probably helpful to clarify in the beginning is why our REST catalog is any different than any other REST catalog. And believe me, they are quite different. Our REST catalog is an open source Apache project that you download over the internet, and you have a pile of source code that you start on your server. So it's not the same as a service that you get from a cloud provider. And that tells you a lot about the kind of people that will be interested in using our product. Almost every financial institution in America has, in addition to cloud storage, a huge on-prem data center in which they have a huge amount of Dell ECS storage, or native NetApp storage that's running a big storage grid, or Pure Storage. And what that means is that the vast majority of your major corporations in America have huge amounts of on-prem storage in which they want their table to be no more than maybe 100 milliseconds from where their query engine is located. And those are the folks who are particularly interested in developing on-prem data lakes that also take advantage of cloud storage for some purposes. And that's the niche that we fill. Those cases in which we have all kinds of engines, as I've shown here, Trino, Spark, DuckDB, a whole variety of them, and I want to unify a whole bunch of data sources. I have on-prem storage because it's vastly cheaper than cloud storage, and my engines on-prem are vastly cheaper than cloud engines. A cloud engine runs, of course, and bills you for every second of every query that you run. An on-prem engine can be of a significantly different cost profile. And that's the reason why many people are interested in on-prem data lakes. Apache Gravitino is a catalog that's meant to fulfill this specific purpose. Because notice on this picture here, I have a whole bunch of different data sources here. And one of them I have underneath the Lakehouse catalog here is Apache Iceberg, which means that we'll stand up an Iceberg REST catalog, but we will also create a federation layer. And underneath that federation layer, we will unify all the other stuff on this picture. Kafka streams, relational databases, on and on and on. So you have a single federated governance environment for all these different things at the same time. You can grant privileges to all these things in a unified way. You get an audit log for all of the things you access at the same time, and you get a unified picture for your AI agent. Now, this structure on its own would have been great in solving many problems. But in the agentic age, imagine how great and valuable it is that your AI agent can get access to all this stuff and provide a comprehensive picture of your entire data estate. And that's exactly what Apache Gravitino is meant to do. Now, what I want to do tonight is talk about IRC specifically. And one of the themes of our evening is what IRC does and does not provide. Because IRC is great. Internet REST Catalog is great. It does a lot of things that are Iceberg oriented. But one of the things that's our theme for the evening is what is agentic that the Iceberg REST specification does not provide. So let's see if we can tackle both of those topics. The Internet REST catalog specification gives you a lot of stuff. It allows you to define tables, namespaces, and views. And that's very valuable. You get a commit protocol so that you can do writes. There was a gentleman here who asked a question about, can I get access to my S3 table directly through Iceberg? You can't do that. The S3 table format is out there on S3, and you could do that. But that would generally be considered a poor practice, because what does the catalog do for you in an Iceberg domain? The most important thing that a catalog does for you in the Iceberg domain is provide something called atomic swap. Now, an atomic swap takes place when I have a snapshot of data out on my S3 storage, and I'm at snapshot number 5, and somebody comes along, they want to write. So they're creating snapshot number 6. It's going to have an insert in it or some change of rows or something of that nature. Now, when that additional write is complete, how does Iceberg indicate when that write is now effective and visible to others? And the way that occurs is that the engine gives it to the catalog, and the catalog performs an atomic swap of 5 to 6, and then every reference from that point is on the new snapshot rather than the old. And this ability to atomically swap is the reason why an Iceberg catalog got started to begin with. Now, we have all kinds of other things that the Iceberg catalog is dependent upon to do. And I've shown here 4 additional things that you're going to see from Iceberg REST catalogs in the very near future. And I want to tell you briefly about these because we're not the only ones. There are going to be all kinds of other REST catalogs that provide this sort of functionality. The first is called fine-grained access control. Today, Iceberg specifications are at the table level. But the Iceberg Committee for about 3 years has been busy on a specification for row and column access control so that you can mask and you can indicate which specific rows of a table you want to see. There's something in the Iceberg specification coming up called a materialized view. How many people are familiar with materialized views? This is an old database concept. You put up your hand, sir. What is a materialized view? You save the table. And when would I do this? Perfect. So I've got a huge join between 2 Iceberg tables. Each table is 150 million rows, and I'm going to do a join between them. How long does that join take? Oh, I don't know. It depends on what my join key is, but it could be 4, 5, 10 seconds more. I don't know. Could be longer than that. And so when I perform that join, I'm going to materialize it into storage so that the next time I want that result, I don't have to compute it again. It's sitting there. Now, we'll talk more about how neat this is and how the Iceberg Committee has defined this. We'll talk about table encryption and disaster recovery from an Iceberg REST catalog. Wow, how cool. Let's start with each one of these. What you're going to find in the very near future, we're working on it right now, is row and column access control from your Iceberg REST catalog. This means that you can specify down to the row or column which columns should be visible, which columns should be encrypted, which columns should be masked. If you are in the marketing organization or the engineering organization or the finance organization, your administrator could say, I only want this person to see the rows that are from the finance team as opposed to another team. Typical use case for row and column access control. And the way the Iceberg Committee is set up to do this is through something called read restrictions. And what that means is that the catalog will send to the engine the specific filtering that it wants the engine to do before you, as the user, see the table. Okay, well, that makes sense. But think about how now that changes the game, because now the engine is a very central part of your overall filtering strategy and is going to have to participate in determining your policy directive because it's the one who's going to make sure that your filtering is done before the user sees the table. So the Iceberg Committee defined this idea called a trusted engine. What's that? A trusted engine is one that has been proven and verified to fulfill the Iceberg directives that are sent to it. If you're not a trusted engine, we can't depend on you fulfilling the directives that you're sent. And so what you'll see from Gravitino is an implementation of Iceberg REST that will send the directives to engines and a bunch of engines who will determine that they want to be trusted. Spark will be first because they implement Iceberg Core. Trino will probably be second. A variety of others will come after that. And so you'll see a whole bunch of trusted engines. And we'll see alternatives for those who are not trusted. Now let's talk about the next topic, table encryption. Wow, table encryption. Well, wait a minute. Why is that so exciting? I mean, everybody will encrypt a table. I can give my table to S3 and it will encrypt it. So what? Why would it be exciting for the Iceberg REST catalog to drive table encryption when encryption is so widely available? S3 will do it. Anybody will do it. And so what's the magic here? The magic here is that in order for S3 to encrypt your table, you have to give it your key. Or it will provide a key for you, and then it will store your key. But what if you're in a regulated industry where that key is everything to you? I don't want to give that key to my cloud provider. And I may have a multiple number of keys because I'm going to encrypt column 4 with a key. I'm going to encrypt column 5 with a different key. That's the level of security I want. And that's where the Iceberg Committee is really focusing on providing these kind of use cases, the security that they demand. And so you're going to see a lot of Iceberg REST catalogs start to come out with table-driven encryption from the catalog. Next, materialized views. We started to talk about this a minute ago. I just did a big join. I'm going to materialize that on storage so that the next time I have to do a join, it's already there and I don't have to recompute it. Now, if I have materialized a big join, what's my number one worry? Staleness. Just read my slides, sir. Did you know that it was staleness? So very good. A+ for the day. Why would my data become stale? New ingestion. I just did a join of table A and table B. And so now I've materialized that, but here's new data on table A. And so my data is now stale. Now, what is your reaction to the fact that your data is stale? That depends. Some use cases are such that some amount of stale data is okay. I mean, this was data that was current as of yesterday, and I've added new data today, but it's not a big deal. In other cases, staleness is a huge deal, right? And it depends on what your use case requires. And so what you'll see, and what we're working on right now, are some catalog-driven policies that will help you determine how important staleness is to you. So look at this picture. I have here a base number of commits. There's S1, there's S2. These are all writes. S1, S2, S3, S4. Everything was fresh until this guy, S4, hits. Now, what did S4 do? It made my data stale. And so here I'm in a stale state. Now, what am I going to do? That's for you to be able to tell the catalog how you want this handled. Approach number one, I don't want any stale data. Do not deliver this materialization if anything is stale. Strict, but understood. On the other hand, it's okay, I'll take it. And you may have a table-driven policy to determine on a case-by-case basis what you want. And that's exactly what we're working on right now. There are a number of other catalogs that are going to do this very thing. One more governance feature that I want to tell you about, disaster recovery. All of your data is in data center A, earthquake. That's the number one thing that we worry about in California. There's been a quake, data centers wiped out. What do? There has to be DR recovery to data center B. Now that's a lot trickier than it sounds, because look what I've got in this picture. I have here catalog state that's being updated along with object storage. And so here I had a write. My catalog was updated and my object storage was updated. And then here and here and here and here. So in a DR situation, I have to update both my catalog and my storage, because my storage is as wiped out as my catalog is. Everything in Northern California was wiped out. I have to switch to another data center that's in Ohio or somewhere like that. Who's going to take care of replicating my object storage? Not me. That's NetApp's job, or Pure Storage, or whoever it is, Dell ECS, who's ever your storage provider has fantastic solutions for replicating your storage. So we have to replicate your catalog, but it gets a little bit complicated. Look at this. We had a DR event right here. And so we have some catalog updates that have not yet been replicated with the associated storage. And in fact, they're not going to be because of the DR event. So we have to keep a current pointer, because there are going to constantly be some number of events that never get replicated to the other site, and we're going to have to switch over to it anyway. This is cool stuff. This is very cool stuff. Now, the Iceberg committee in Iceberg v4 has defined something called a path relative reference. And I want to tell you about a path relative reference. Today, if I have storage here that I create a snapshot in my Iceberg metadata, what will it say? I'm a table, and I'm located at S3, name of the bucket, name of the folder, name of the folder, name of the folder, name of the table. The entirety of my fully qualified name is in that metadata. You can trace my exact location with the metadata that's in there. Well, that sounds nice. What's the problem? The problem is that when my storage is replicated to a new place, it says my table is at that old bucket, the old directory, the old thing. There's nothing correct about this anymore, because I just replicated my storage to a path relative, a fully qualified path that's wrong. You see what I mean? And so the Iceberg committee has defined something called path relative indexing, which means you'll have a bucket name, and then you'll have some number of directories that your directory is located at. And then you'll give the name of your thing, so that when it's copied over, all I have is the part that's still correct, and the base part is what gets to change. Now, until we get that, whenever it is, we have to kind of work hard on DR, because we have to sort out what part is no longer correct and suppress that manually, so that when you're operating on copied storage, we know that you're not really at the location that your table says you are. Wow, amazingly good stuff. So the point of these 4 items is that the Iceberg people are doing amazing things to improve the governance of your tables. And all of the Iceberg REST catalogs are going to be improving their implementations of these categories. So what's missing? The thing that is not being delivered, that Iceberg isn't even trying to do, is to expand meaning, which in the agentic age is incredibly important. because the selection of the table by the AI agent is determined by the meaning that you tell it about what all these tables are. I have to compute revenue. Which of these 10,000 tables in your data lake do I use? Which row do I aggregate? Which join do I perform? Now, how am I supposed to figure that out? I'm the AI agent. I'm going to read the schemas of all 10,000 of your tables, and I've got some that say some number of things up there, and so I've got to guess as to how you compute revenue in your organization. But that's too hard. And that leaves the door open for a million mistakes. And so what we have to do is to get the agent more semantic meaning. And we're going to do that through three basic approaches. Start at the bottom on this picture, we have sources and we have federation. Now, I mentioned that this is what Gravitino is fantastic at. It was created as a federated catalog. And so you have Postgres, you have Iceberg, you have Kafka, you have unstructured data. We'll federate it all into a single API. That seems great. So what more can there be to do? We have to give the agentic experience more data about what all these tables mean. And we're going to do that in three ways. Number one, identity. Extremely important. We've had speakers tonight talk about OAuth, and that's the primary way, but we're going to enhance that. Way number two is through governed access. This is like FGAC and other mechanisms so that you can control down to the row and column level what you allow your agents to see. And the third is data modeling, so that your agent understands the relationships between your data tables and which ones convey the meaning that you intend them to have. Now, let me say a little bit more about each one of those three layers. We're starting with identity. Well, that's neat. That's a nice concept. Everybody knows about the identity provider and the JWT, and okay, so that seems fine. Now, what you're going to want to think about in the agentic age is that the agent is the one operating, and who is the agent operating on behalf of? The agent is operating on behalf of me or you, the user who has logged into the agent. And the identity that they're going to take is not their own, because the identity that the agent has is a service user who's highly privileged. I don't want this agent to see every table in my environment. That's crazy. No, there's no way. That's entirely too. So I want the agent to swap his identity for the logged in user. And in some cases, I even want to have less identity than the logged in user. And so we have this RFC, request for comment, which is a typical internet kind of standard mechanism that specifies a practice called OBO. And what it means is that the agent trades its identity for the token representing you, the user. Now the agent is operating on behalf of you. You're the one who has the privileges here, not the agent, which means that right away the agent is operating as you. Much better. And where we'll go from there is to have further restrictions on who you are so that you can specify, I don't want the agent doing everything I would do. I mean, I can delete my account. I don't want the agent doing that. And so there'll be tiers of OBO that specify exactly what the agent can do. Neat. The second, in governed access, involves a technology called OPA, which is a filtering engine. And the exact name of it here, Open Policy Agent. Open Policy Agent is currently supported on Trino, and there are a variety of other platforms in which it's available, and it's going to soon be available on more. OPA is a rule mechanism that's supported natively on Trino in order to help you specify what actions Trino should take before it presents a table. Remember a second ago that the Iceberg Committee has adopted a mechanism where you specify rules that the engine must follow before it gives the user a table. And an OPA mechanism is very, very similar to that, with the difference that an OPA mechanism can apply to any table that Trino touches. And so you put in rules, and in fact, what Gravitino will do is put in rules that say, filter these tables, filter these columns, suppress these rows, and what you have is row and column filtering across your entire data estate. So then there's a bunch of mechanisms about how do the rules get in there, and how often does Trino get updated, and what is the bundle like of rules? And we'll help you understand all that. But the times are exciting because you're going to soon have row and column filtering across your entire data estate. What that means is that you'll have three different roles: the author of a policy, the decider of whether a row or column gets visible, and the enforcer. And therefore you have a PAP, a policy author point, a PDP, a policy decider point, a PEP, a policy enforcement point. One of my customers of Gravitino actually created these mechanisms, and he published a paper on it. So this isn't stuff I've made up. I wish I could say I had, because it's pretty nifty. But it indicates the niceness of this system here. You specify a policy. That policy gets translated into an OPA engine, and the enforcer is your Trino who will determine at query time what should be visible. Wow. Very cool. So things are getting good. Things are getting really neat. Here's how OPA bundles get transferred around. We already talked about that. Now, we're getting to the point where we're ready to talk about what happens once we have mechanisms to completely enforce everything we want. We're ready to express a query. What have we got? Well, we have views, Iceberg views. Okay, well, uninspiring. What is an Iceberg view? It's a SQL statement. Select this from that. Okay, that's nice. But if I really want to provide a higher level abstraction that indicates what my metrics are in an organization, a view is just not going to cut it, because I would have to have a dozen views. I have to have a view for computing revenue this quarter, and then I have to have another view for computing revenue next quarter, and another view for computing revenue by region, and another one for computing revenue with discounts applied, and another one for computing revenue if no discounts are applied, on and on and on. And so what we're going to do is we're going to get rid of that view concept, and we're going to have something called a structured metric. And there's a standard currently available called OSI, Open Semantic Exchange, and an open source Apache project called Ozzy that's making all this real. The idea of a metric is that you will use YAML to define how you want your basic business terms computed. I have a basic business term called revenue, and here's how it's computed. You do a join of this and this, and you look at this table, and you filter out this stuff, and it could be very elaborate. And then you will specify all of the other filters and aggregations that you want to apply. I provide revenue by geography. I provide revenue by quarter. I provide revenue by 6 other different ways. And then when you exercise the metric, the catalog will convert your YAML to SQL and provide the result to you. It's an elegant and beautiful system. And so what I suggest, if you're interested in this topic, is that you could pull something about open semantic interchange or tell me that you're interested in this, because we're building this right now and we plan to make it available soon. And so if this is interesting to you, I'd love to talk to you more. Now, once you have a series of metrics, you have one final step, and that's to create an ontology for your data. Is an ontology an idea that's new for people, or who's familiar with an ontology? Okay, a couple of people. Okay, yeah. An ontology is a graph that shows the relationships between your data and the important business concepts in your organization. So let's take an example. If I'm a bank, I have an ontology that all ontologies are graphs of concepts and how they relate. And in fact, I've got an example here that all ontologies are what are called RDF, Resource Description Framework, which are tripled. There's a subject and a predicate and an object. And my ontology is just going to be a successive string of triples in which I have things like, I'm a bank. I have customers. They have accounts. Accounts have transactions. Transactions have, and you can just imagine it goes on from there. Now, this is an insanely simple topic, but yet very powerful, because I can express the fundamentals of almost any business in triples. I am a heating and air conditioning provider, and here's the ontology. I have a building. That building has floors. Those floors have zones. Each zone has a thermostat. That thermostat has a certain number of sensors. There's your ontology. Wow, this is cool. Now, what do I do with that? I affiliate my concepts with tables in order to guide the AI agent in how to manipulate my data. And then I share these ontologies with the agent itself. So here's a handful of triples that have built a complete RDF, and I can have triples expressed in a couple of different formats. One is called a turtle file. One is called a JSON LD file. They're exactly the same. They're both standard ways to express ontologies. Gravitino is not the only person or the only catalog. I don't know if you noticed, but Databricks just announced a couple of weeks ago that the Unity catalog would start reading and writing ontologies. Wow. And so agents are going to get a big boost, because they're going to have from you the ability to understand the semantic meaning of data. More terms. What have we done so far? Let's see. We've got RDFs and turtles, and now we have OWL, which is the expression of the classes inside a triple. And so rather than to have an undefined list of all the various things in my ontology, I have specific things. I have a customer, I have accounts, I have preferred customer, I have tax ID. This customer is a subclass of that. So an OWL file is a way to define the concepts in my RDF. So here's the whole zoo. I have an RDF file. that's made up of triples. Those triples are expressed either in a turtle file or in a JSON LD file. The OWL is used to define the classes that are within that, and I use something called Sparkle to query my ontology. Wow. This is how it's going to be used. We have a whole bunch of concepts here from our RDF, customer, tax ID, and we are going to associate each one of those with a governed object in your data lake. These are tables, or they could be groups of tables. And once the agent knows, natural language query is going to become the simplest thing in the world, because you give it a natural language query. For each customer that has this, how many accounts, then we're overdue, and okay, whatever, all that. And the agent is going to use MCP to say, well, let's see, what have I got here? I've got accounts, I've got customers, I've got okay, well, I know how to join these. I know the relationships, boom. And suddenly the quality of what your agent delivers is insanely high. So here's another example. Show me West region customers. We're going to start with natural language query to my agent. We're going to find metadata. We're going to do a governed read through an OSI metric, because I haven't just given it a vast sea of data. I've said, I have a governed metric that I want you to use, this one right here. And I've already defined it. You don't have to guess. And so all it has to do is execute that. Suddenly, agentic queries are dramatically better. So, kind of wrap things up here, what I've tried to make a case for today is that we're at a very interesting turning point. Iceberg catalogs are developing a huge amount of governance capability, fine-grained access control and DR and materialized views. So the speed and comprehensiveness of your queries are going to be better than ever before. But now you're going to have semantic information on top of that that's going to dramatically accelerate your agentic experience. Now, I mentioned we're building all this stuff now. And one of my goals in being here is to make you aware that we would love to talk to you if any of this stuff is interesting to you. And so there's how you reach me, or here's how you reach Apache Gravitino, an open source Apache project. You could go there right after this meeting. You could download it. You could install it. It's fun. You're going to have a lot of fun. And in the future, I would love to talk to you about RDF files or materialized views or anything we've talked about today, because there's a whole bunch of exciting things coming. Any questions that I can answer before I go? Yes, sir.
So you've described a lot of entities. Is there some transactional model that unites these so that they don't change and result in inconsistent definitions?
There are a number of them. And so it depends on what industry one's in to determine what your RDF file is going to contain. If you're a bank, there's a standard called FIBO that defines what your ontologies will probably define. If you're in other industries, there are trade associations for a variety of them. And if you're in no formalized environment, the catalog will probably make it up for you. Databricks just announced, when I mentioned that they were going to read and write ontologies, that they said, we will look at your query log and define your ontology for you. Wow, that's cool. And so these are catalog managed files and relationships. Yes.
Thanks. I have two questions. The first one is, I didn't quite understand the difference between Aussie and ontology. If you could maybe explain that a little bit.
Between Aussie and ontology.
Yes.
Okay, that's a very, very good question. Aussie is an Apache project that was named after that, I guess it's a kangaroo or something like that, And so it's an open source project. Usually Apache open source projects have unusual names. I have learned through experience. Gravitino, I don't know exactly where that name came from, but Apache projects, they have all kinds of crazy names. Aussie is an Apache project that is delivering OSI metrics. Open Semantic Interconnect. OSI is the technical standard that's defining a set of YAML specifications for governed metrics. And so I was saying that today you may have a view that defines revenue. Select this column, take an average of it over this period of time. But nobody is able to have just one view for something like that. So then I have another view and I have another one that depends on whether or not I want the discount applied, or whether or not I want it cut by geographies or cut by departments, or, on and on. So pretty soon I've got a dozen views for revenue. And that's just not tidy. And so the idea of an OSI metric is to say, I have this concept in my business called revenue. And here's how it's defined. You take a join of this and this, you filter this and this, and you can get as precise as you want. And then you can define the aggregations or filters that are applied to that concept. Wow. So there's a lot of precision. Now, when the AI agent gets a natural language query that says, what was revenue? There's no guesswork. It goes to the list. It sees a governed metric for revenue. Bob's your uncle. You're done. Now, the ontology is an expression or a tree of concepts that define relationships between either data or governed metrics. So if I have a table of accounts and a table of customers and a table, I'll have an accounts that'll have a one-to-many relationship with transactions, that'll have a one-to-many relationship with something. And so the agent can see this and it can say, oh, wait a minute. I know exactly how to answer what accounts are more than 90 days overboard and this and that and this and that because I read the ontology and I can see how these things join and what their relationships are, or what the appropriate OSI metrics are, and it can translate a natural language query highly accurately.
So an ontology could be thought of as like a something that defines the relationships between different Aussie metrics. Is that it?
That's right. Different Aussie metrics or different tables.
I see. Okay. Thank you.
Now, the important thing about a metric is that it's usually one item. And so revenue is an example. And so if I want to compute revenue, I have a governed metric that says revenue. And when I run it, I get one number because it's revenue this quarter or whatever my metric is meant to define. Now, there's a lot of agentic work that doesn't resolve down to one number. It resolves down to a group of rows or a bunch of rows, or who knows where from there. And so that's where you start to leave governed metrics and get into tables and their relationships so that the agent can see how to join in order to translate a query.
Thank you. My second question is about you're talking about trusted engines earlier, right? They are still honorary, right? They are not, for instance, if a malicious user could just write, or maybe by mistake write a random Spark query that doesn't necessarily have to follow whatever rules the catalog sends, right? They can Spark can, for instance, just arbitrarily access columns that it is not supposed to, that user does not have access to, right?
Okay, so that's a really important point. And I think that we were talking about, this gentleman's question is about trusted engines, is what I was talking about. And the reason why it has to be a trusted engine is because you're going to define a policy into the catalog that says, I have a table here, and several of these columns contain PII information. I've got somebody's social security number in a
Right.
big table. And so I don't want most people to see that. And so I'm going to put in a policy that says, unless you're Joe, everybody gets this column masked. Nobody gets that. Okay. So if you're another identity, when the catalog sees that you're querying that table, it will issue an instruction to to Spark or whatever your trusted engine is that says, here's the whole table. You are on your honor to mask that column because Joe's not the one performing the query. That column has to be masked. Now, why can't the catalog just do that? Because in the Iceberg system, the catalog is not on the query path. It's on the query path, but it's not on the data access path. And this gentleman here put up a slide that was extremely helpful in this regard because here's the way Iceberg works. You are a user. You've got a query engine. You go to the catalog. You say, I want the revenue table. The catalog says, okay, here's a pointer to it. And then what do you do in step 2? You go over to S3 and you say, I just got this pointer from my table, hand it over. And so the data comes directly from S3 into Spark. So now I've got all the data. Wait a minute now. That's where the problem arises. I don't want everybody to see that masked column. So the catalog is going to tell the query engine, don't show that table unless you're so-and-so and so-and-so. And the engine has to be trusted to deliver the right answer.
Yes, but that's the problem in my opinion. I mean, we are developing a solution in Spark to try and address that. I think Databricks already has, I think it's done through Spark Connect so that like there's no way user can manipulate it or something like that. But the other point in this regard that I didn't quite understand is, so catalogs like Gravitino and Polaris, they provide scoped credentials, right?
Yes.
So let's say a table has like 10 columns. Now each of these 10 columns, why can't the catalog provide scoped credentials such that only, okay, this particular user has should only be able to see these 3 columns? Why can't why can't it send a scoped credential that can only read those 3 columns instead of like the other 3? Why should it rely on the engine rather than maybe just give it a credential that so that if the engine tries to read a column that it's not supposed to read, it'll just crash it? Why?
Okay, that's a great question. Then here was another design that was contemplated. The other design, primarily that was contemplated, goes like this. We have to mask that column. So the catalog is going to not provide the table. It's going to provide a view. And the view is going to have the mask in it. So the only thing the engine needs to do is execute the view. and there's nothing else it can do. And so therefore, we don't have to worry about restrictions to the engine. We just hand it the view that we want executed. Now, there's actually a bunch of interesting technical trade-offs about whether or not that's the right answer in all situations. And then the catalog is materializing views, and that gets to be kind of a thorny set of issues. So that's there's a whole bunch of trade-offs one way or another. One reason why that's hard is because you may institute a policy that says, I want half of this value masked. You know, how way Social Security's numbers are. It's like the first 4 numbers are seen, the second 4 are masked, or whatever, whatever that is. And so there are cases in which you have to see part of the number, or you have to operate on part of the number, or, it actually gets pretty thick. And so the engine, in many cases, has to get involved to do the right thing.
I see. Yeah, thank you very much.
Files, but like row level, I'm not sure if it's even possible.
Yeah.
Columns are like within still a Parquet file. Like you can, I would have thought like, okay, this file would get like a scope credential, but like columns are still within a single file, right? Whereas rows could be like across different files. So let's say you can say you should not have access to, if this column is greater than 1,000 or something like that, all rows fitting this filter should not have access to those. If there are in separate files, then potentially scope credentials can work. But if it is in the same file, wouldn't
It would sometimes be in the same file, or it'd be in different
Yes,
files, depending on the schema, the size of the table, et cetera,
Yeah.
because the columns can be in different Parquet files, depending on the schema and the size of the columns in the table, or it can be in the same file. But in almost all cases, you will have partial in some tables that have a variety of values. And so you have to get down to filtering between the items in a file. So you're absolutely right to mention that. I think I've probably used my time, and I want to be careful about the length of time I'm going here. So, but we're having fun. Any other questions before I go? Yes, sir.
Okay, so from what I understand, Gravitino adds a semantic layer on top of their data, right?
So Gravitino will have a semantic layer on top of its data.
Okay, during the first presentation, I asked a question about when we have a boundaryless lakehouse, how can we feature engineer and how can we make sure that those features are consistent? Can we use Gravitino to have that structure where multiple users are trying to extract features out of the same data set?
So I heard you ask that question because I was sitting over here, and I want to understand when you say different features out of a data set, what do you mean by that?
I say like trying to correlate different things together. Sorry. Or
Well,
like just
I think the general answer is yes, you can do that because row and column filtering is sensitive to roles, which are groups of users. So I can say, you, user, you get these rows and columns. This guy, he gets different stuff. Could be completely different stuff. Could be some of the same stuff. But that's what you get to specify that comes through because you have identity that's matched with the filtering.
okay.
Does that answer the question?
It does, yes.
Okay.
I mean, I still have to learn a lot more, but
This is fascinating stuff and it's fun. Okay, well, again, thank you very much. It's been a pleasure being here.